We will attack Google Chrome extensions, and the purpose of this talk is simply to show you why Google Chrome extensions are an easy target, why are they targets really attractive to look at, and you also will be given tips and tools that will help you in doing research on Google Chrome extensions on your own. My name is Krzysztof Kotowicz. I pentest for these beautiful companies. I also research some client-side vulnerabilities. I also blog, tweet, and blah, 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 blah. But this is not the talk about me, but about Google Chrome extensions. So what are Google Chrome extensions? Firstly, these are not these are not browser plugins. So Google Chrome extensions is not Java plugin, it's not Silverlight, it's not PDF reader. Google Chrome extensions and browser add-ons in general, they are basically HTML5 applications that enrich your browser user experience, and they allow, by installing extension, you give your browser additional functionalities, or the website gets enriched in a certain way. There are multiple extensions for doing some online bookmarking, for doing some page recommendations, some notebook taking extensions, some web developer oriented extensions, etc., etc. And the most important slide, I think, is this in this talk. Why are they interesting as a subject to research, and why are they why anyone would want to look at the security of Google Chrome extensions when there's a lot of websites that are already vulnerable in multiple ways, and there's vulnerabilities being discovered like almost daily. There's a lot of pen testers doing this stuff every day. Well, Google Chrome extensions are basically HTML applications, so they suffer from the same vulnerabilities as the usual websites, but at the same time they have higher privileges than the usual websites. For example, it's of course defined, it will be defined further on during the talk, but in theory, then they can read and write all the cookies, including the HTTP-only cookies. So they are really a good subject to start a session hijacking attack. They can even change your proxy settings. They can block requests that your browser is trying to send over HTTP or HTTPS. They can take screenshots of the websites. There's like basically most of the extensions, when they are being exploited, form like a universal same origin policy bypass for all the website that the user is visiting. So this makes them really interesting. And how are they built? Well, a bunch of files packaged in a zip file. It's also being signed with a developer key. So just like a usual mobile applications on different platforms, it's a similar infrastructure here. The file has extension CRX, but that doesn't really matter. How do you install a web extension? Basically, now you can more or less only install them through Chrome Web Store. So these are curated by Google. Of course, there are some ways to install them from the third-party website or from just manually installing a CRX file, but these ways of installing extensions are made deliberately more and more difficult for the common users. Of course, as a power user, let's say you have a way to do it, but it's not really easy in the let's say, social engineering scenario. Extensions have a few distinctive components. First, you have a manifest file, similar like in most of the mobile applications. The manifest file lists all the components embedded, defines the application permissions and stuff. And there are two other components that we will take a deeper look during this whole talk: content script and view pages. So what about manifest file? Well, it's just a simple JSON file with the name of an extension, description, and stuff. Here's the permissions that I am going to describe later. But one of the most important sections is the content script section of an extension. And here, as you can see, there are two entries. First is matches, and it's simply, let's say, a regular expression or a form of expression which defines on which websites is the extension or the content scripts listed here, on which website are they gonna run. So as long as the URL matches to that setting in the extension, alongside the usual web page DOM and usual web page JavaScript code, your browser loads up this content script. In the case of this example, there would be actually two content scripts, the jQuery library and the second script. And this is one component type of Google Chrome extensions. The second one is related to the user interface of an extension. Extensions can have like some little buttons on the interface. They also have like an options page and stuff. And the actual document that loads up here, like in a sort of a pop-up or something like that, is actually, of course, constructed by HTML. And this HTML, this document that is being loaded, is called the view page. To make things more complicated, there's a special kind of a view page, which doesn't really view because it's invisible. It's called a background page. And background page is really interesting because it's the page, it's the document that lives throughout the whole browser session. So it runs constantly in the background. So as long as you can execute code in that domain, it's persistent. Some extensions also bundle NP API plugins. These are simply binary code compiled for the architecture that the browser runs at. So these are packages as DLL files or SO files. But not a lot of extensions use actually NP API plugins. For a good reason. What about the security of the extension? So how do all those components talk to each other, let's say? Well, the first part, content script. Well, the content script runs in a context or in an origin of the web page that is being displayed in a certain browser tab. So, of course, it can access the actual DOM. Elements, DOM tree. It can modify the DOM to enrich a website to, let's say, I don't know, caption all the images, for example, or insert some additional toolbars and such. It does so using the standard JavaScript DOM accessors like inner HTML property or document cookie, document title, whatever. So there's a way of exchanging information between the website and the part of an extension called content script. But at the same time, content script cannot talk directly to the JavaScript running within the web page. So it cannot call functions. It cannot be called from the original website. So there is a security boundary here. Content scripts also get access to the powerful XHR object, which is used to submit, let's say, AJAX requests. But this one is much more powerful because it's cross-domain. So website of origin a.com, which has a content script running here, can also query the b.fr domain documents and read the responses back. So this much about content scripts. When it comes to view pages, they can communicate with content script and the other way around only by sending messages and receiving responses, similar to, let's say, HTML5 post message API. So there's also no direct DOM access from here to here. There's no direct function calls and such. It's just exchanging messages. But view pages and a background page can instantiate dynamically instantiate new content scripts, which is a form of an eval, because you can directly pass the code as a string parameter here, and it will get evaluated as a content script in a context of the web page that is being viewed. View pages and background page are the only components of Google Chrome extensions which get access to this powerful Chrome extension API. This is the hard stuff of an extension. I mean, with using this API, the extension can actually change your proxy settings, monitor your requests, access your history, access your cookies, access your opened tabs, take screenshots of your websites, access the data that you pasted in a clipboard and such. Also, only view pages and background pages by default can call NP API plugins. Of course, as similar to what mobile applications on most platforms do, extensions have permissions. So there's a closed list of permissions that the manifest lists as being required for the extension to work, and upon installation, the user has to agree on those permissions. To sum it up, there's a kind of separation of powers when it comes to the construction, to the architecture of Google Chrome extensions. On the left side, you have content script, which have only the access to the DOM and to the XHR object. And on the right, you have much more powerful components, which get access to all these interesting APIs, including the binary code when in the form of NP API plugins. And between them, of course, there's only exchanging of messages. This right side is limited by permissions, and this left side is limited by URL whitelist, because the extension doesn't run on pretty much any page. It's also defined in the manifest. So extensions are HTML applications, and there's a lot of them. So no wonder that the most prevalent HTML or website-related vulnerabilities have taken place. And of course, I'm talking about XSS. View page DOM XSS was really bad thing like a year ago. Because there were many extensions which were vulnerable to DOM XSS, because basically when you're designing web applications, no matter if they are Chrome extensions or websites, it's easier to write a vulnerable code than it is to write a safe one. So how does a typical XSS take place? Well, in this talk, I will focus on vectors employing a malicious website. So the model is user has a certain vulnerable extension installed, and he visits a malicious website which tries to exploit the extension. So basically, we have a payload in the web page DOM. Let's say it's in a title, and let's say it's a bookmarking extension. So with acting upon extension on some way, with its user interface, or by, I don't know, clicking on a button that the extension has provided in the website, bookmarking happens. So, of course, the content script fetches the payload from the DOM into its own variable. Stuff happens, and then the extension forwards it to the view page by sending message with the title of the page that user wants to bookmark. And then the view page does its logic and decides to display the title of the website back within its UI, let's say in this pop-up here. And we have classic DOM XSS vulnerability. But it's not a DOM XSS in just a website. It's an XSS in view page of an extension. So we get access to all the APIs that the extension was permitted to access. And we can also really simply run in the background because that previous page is actually just displayed momentarily when the user presses the pop-up button. And then it disappears and gets destroyed. So we can nevertheless very quickly migrate our code to the background page by simply calling Chrome extension get background page. This is the reference to the window, and just accessing the eval function and calling it. So, example of an extension which is vulnerable to this. For example, a Slick RSS Feed Finder 1.3. It's an extension which helps you subscribe to RSS feeds. So it looks for certain elements in a page and displays a button. Hey, there's a feed available. Would you like to subscribe? You click the button, you subscribe to an extension. Of course, in the most ugly way, there's DOM XSS vulnerability because it displays the title back. So the usual payloads, and I think the demo is, yeah, the demo should happen right now. So let me just, here I have just the usual exploit here, alert document.location, right? So by just going up, which extension was it? Slick RSS, right? So as you can probably see, yeah, this is the icon of an extension. I just click it, and this is my location. This is not my usual website, dev.localhost. It's my Chrome extension origin. So this is kind of a proof that I have a lot different privileges right now. Another kind of vulnerability, which is far more, I would say, scary, but fortunately it's not that common. It's when you have NP-API plugin and a binary code vulnerabilities inside. Usually it looks like this. There's also a malicious payload in a DOM. It gets transferred to the content script. It gets transferred to the view page, and a view page accesses a method that is exported by the NP-API plugin. And in the parameter, we have the payload. And NP-API plugins are simply binary code. So as long as they have some binary vulnerabilities, like command injection, for example, or a buffer overflow or whatever, we can exploit it from the web page. And the interesting thing is the code running in an NP-API plugin runs outside any Chrome sandbox. So it's just, there's no need to escape from a sandbox, which gets much more and more expensive, let's say, throughout the years. And it runs with just your user permissions, the user that runs the browser. So as long as you exploit it, there's, let's say, a shell on the machine. I was able to find an extension vulnerable to this vulnerability, and I was able to successfully exploit it. Let me talk about CRGPG extension. Of course, this one is already patched. Like when I published the blog post, it was a few months ago. It's an extension which tries to marry together the Gmail interface and the GPG binary, which seems really what could possibly go wrong thing to do. And that's exactly what happened. It enriches the Gmail interface with certain buttons or links to decrypt message, verify messages, and when the user, of course, clicks on those, it forwards the actual, let's say, cryptogram or the plain text to the actual GPG binary and reads the response back to replace it. So there were two vulnerabilities which combined made a really nice exploit. The first one was that actually this extension accesses gmail.com, which is a really fun thing to do. By the way, if you have a content security policy within your website, I can still access it via Google Chrome extension, which is neat. Usual thing, I as an attacker send an encrypted message, encrypted with your public key. You have an extension installed. You press the button to decrypt the message. And within that message, there's an HTML with JavaScript. And guess what? It's being directly inserted via inner HTML. This is, of course, the jQuery wrapper. It gets inserted back in the Gmail interface. So Google as a company, as a let's say webmail filter, has no possibility to actually filter out the malicious HTML because it only got access to the encrypted content. So this was the first vulnerability. So I could get access of your inbox when I send you an encrypted message and you decrypt it. But the second one was actually the command injection in the NP-API plugin. This is the function that was vulnerable was the function used to encrypt message. And when you encrypt message with PGP, you usually need someone to encrypt it too, because you need the public keys. So the list of recipients came from the Gmail. And as you can probably see, there's something fishy going on because there's a lot of command strings appended to each other and then later on executed. But this one is actually email addresses of the recipients. Of course, they weren't filtered, they weren't validated. Of course, there's a like classic command execution vulnerability. So I sent encrypted email, you decrypted it, and I have a Metapreter shell on your box. So that was that's the proof of how a developer can kick themselves in the foot when using NP API plugins incorrectly. There are tools for exploiting Google Chrome extensions. One of them is, for example, the Beef module. Beef was already mentioned. It's a very neat tool to exploit XSS, basically. And one of the modules is a fake flash update module. The idea is they created an extension, gave it all possible permissions, injected. The extension basically injects a Beef hook, so basically XSSs every website that the user visits on every tab, and they package it as a Adobe fake flash update module. And of course, you need some social engineering to convince the user to install the Flash plugin. And actually, it was easier back then. It was easier, like say, a few months ago, because it was very easy to install extensions from a CRX file. You just needed to drag and drop it. But then Google changed things. So they actually tried uploading this particular extension into Google Chrome Web Store. And guess what? It got accepted without a problem, and you could download the extension straight from Google Web Store. Yeah. So this is the project of Beef. I took a different approach. I developed a framework called XSS Chef, made specifically for exploiting XSSs in Google Chrome extensions. Basically, it works similarly to Beef. There's a really short payload that you need to inject and execute in an extension that is vulnerable. And once you execute that piece of JavaScript, I get a connection via WebSockets protocol to my server listening for commands to control, and I can command applications to do neat stuff via just using web application on the attacker's box. So I can browse all your browser tabs. By the way, also the one in the private browsing mode, because so it's not really private anymore. So yeah, so I could do that. I could execute JavaScript on pretty much any domain. I could grab Google Contacts via just sending requests to this particular URL, based on the fact that the actual requests are being made by the victim's browser with all appropriate cookies and stuff. There's also many payloads prepared within this tool, like, for example, set proxy settings. So as long as the extension has the necessary permissions, you could set up a HTTP proxy within the browser. And this is really interesting because there was no way for the user to actually change them back, because once you get to the proxy settings in your Chrome simply says, sorry, you cannot change proxy settings because those are managed by the extension. And it doesn't even say which extension does manage it. So yeah, you could do that. You could, for example, add persistent scripts, which kept on running on every tab forever. And this particular payload just looks for the forms with a type, with input of type and password, and forwards it back, so I get all your credentials on any website. So this was the thing. Let's say a year ago. It was really happy exploiting period, because you could more or less download top 10,000 extensions, run some grep, spend maybe one day and you get 10 extensions with vulnerabilities. You just looked at which one is the most popular, prepare the payload for that, and start poking around. But that is usually the thing when XSS is so popular. So Google introduced, around a year ago, they introduced something called Manifest version 2. And of course, Manifest version 2 extensions most of the times need to be rewritten. So it's not just changing one file, it's basically changing the whole extension most of the times. And the most important thing in Manifest version 2 extensions is the content security policy. This is the more or less default. I've omitted some declarations from content security policy, but this is the default one enforced by Google, and it's not really we are not really able to relax it even. So basically, what it says is no inline scripting is allowed in Google Chrome extensions code, and no eval is functioning by default. Basically, that means no DOM XSS. Sorry. So that's not really a fun thing for a security researcher, and not fun thing for malware authors, I guess. But well, that's the world. And what's the timeline? Currently, in September, Google Chrome Web Store will delete all V1 extensions. In January, Chrome stops loading V1 extensions. So all the tools that we have developed over the last year will simply stop making sense, because there's no code vulnerable to that. Currently, almost half of the extensions are V1. So a lot of extensions will probably die out. Yeah, but there is still a way of attacking V2 extensions. A way that will probably be still left by Google, because there's kind of by design thing, and I'm talking about content script DOM XSS. How does it look like usually? Well, you have the web page DOM with some secret payload crafted for an extension. It gets fetched by the content script. And actually, content script could simply eval that or insert it back into the DOM, and that would be the shortcuts to the whole execution path. But most of the times, what happens is that the content script forwards it to the view page. View page does its stuff, and then calls a new content script, Chrome tabs execute script. This is the function to instantiate a new content script. And of course, it does so insecurely by appending strings without validation, without any form of input filtering. Yeah, and we have the XSS. And the question is, what do we achieve via this XSS? Well, we can, as we are still in our extension context, so we are the content script code, we can send requests back to the extension backend, but this is rarely exploitable. What we can do, though, is we can issue the cross-domain XHR. So if I exploit an extension from mymaliciousPage.ch, I can issue XHR requests from all the other domains with all your other cookies. Unfortunately, there's a whitelist for the URLs that can be queried or can be fetched remotely. But you know what happens when you offer a whitelist to implementers? Well, this happens mostly. So almost half of the extensions by my rough query just uses the wildcard. So exploiting half of them will simply allow you to query almost any website on the internet and get the responses back. So basically do the universal session hijacking, let's say. Example of an extension which is vulnerable, of course, this is current version. It's an extension called Easy Link Preview, and what it does is it offers link previews. So basically, it adds a ton of stuff to the original web page DOM, working on mouse over events and stuff. And basically, you can right-click anything and preview the links in a certain pop-up or something. But you can as well, for example, save a link to Google Bookmark. So not the actual page that you are at, but the link that is being displayed over there. What it does is it fetches with Ajax. It fetches the target of the href. It looks for the title with this silly regular expression, extracts it here, and uses the Chrome tabs execute script, with just a really scary string concatenation here without any escaping whatsoever. So classic DOM XSS sync, right? So let me show you a demo. If you can see, all those easy buttons are actually this particular nasty extension working. So easy preview dot zero is an extension which looks like this, right? Just a payload in the title. No fun here. So I just right-click this little fellow, use the save link to Google Bookmarks, and I get the, as you can see, my URL is currently the web page. So I'm in the context of a web page. But there's more that you can actually do. And what I did is I created a tool to actually abuse this vulnerability. It's called Mosquito. It's called Mosquito because it contains malaria. Malaria is a project from, I think, 2 years ago or something by Erlend Oftedal, very smart fellow. He was trying to develop a proof of concept that insecure cross-domain XML files, I think that's what Flash uses, that wildcard cross-domain XML files are really a bad idea for a website to have. So he developed a tool, and I just used his tool within my toolkit here. If I could describe the project shortly, it's just you can use XSS in an extension to make it a HTTP proxy. So the thing is, there's a whole, whole chain of things, but basically, you have an XSS in a content script, which you abuse to evaluate a certain payload, and then on your attacker's machine, you have a HTTP client, like let's say Burp or just your browser, basically. And you issue HTTP requests. And those requests travel to the extension and they make the AJAX request. The browser happily attaches cookies, and this is the most important part after all. And then I get the response text back, which is what you usually don't have for cross-domain requests. And the responses, of course, travels back to my tool and to your HTTP client. So let's look at the actual toolkit working. There's a magic file called run.bat. A few toolkits launch up. I'm waiting for everything to start up. Yeah, everything seems to be working. So, yeah, so there's a neat Mosquito hook generator. It's just a short JavaScript to be encoded. It basically loads the main payload and evals it after all. The defaults are okay for me, so I will just copy the vector to the clipboard, and I will use, here's the EasyLink preview, yeah. So as you can see, I'm abusing the fact that the extension appends strings to evaluate JavaScript code. Everything is okay, I guess, plus eval. Yeah, there's some enter here. Doesn't need to be here. Yeah, I think I'm done here. So observe this area here. So basically, this is my malicious website, right? I saved the link to Google Bookmarks. And yeah, it connected to Malaria server. So I can use my Burp proxy. Observe, this is my localhost proxy. This is the actual window to my extension. And as you can see, I can issue queries to cross-domain. This is a different domain name. And yeah, this was the extension actually making the AJAX request. And as you can see, probably, the window is very small, so I will need to, yeah. The window is very small, though you would probably, will be easy to see. I'm trying to find the HTTP user agent. Where is it? Where is it? It's somewhere at the bottom, I think. Ah. I just look at it here. Yeah, as you can see, I'm Chrome 27, so this is the browser that I hijacked. As well, I can, of course, fetch the Hacking Paris website. But what is really important, I can also, well, this is a little bit trick. I have no time to explain why HTTPS works like this here. But basically, I can fetch the Gmail account. And these are the emails of my victim. So the extension allows you to simply browse the web as your victim would be. So basically, that's it. I mean, what I would like you to remember from this talk is that the extensions are HTML applications. They suffer from the same web vulnerabilities. I've only described XSS, but there's a few interesting as well. They are also very easy to exploit because basically no one looked at them hard enough. So there's just, I guess, a bunch of guys doing that as a hobby or something. It's still possible to exploit Manifest v2 extensions, contrary to popular belief, even though they have content security policy. And when you exploit an extension, you get so much more possibilities that there's actually no point in exploiting simple websites when you get so much power from exploiting something else which is commonly installed. And of course, there are tools that can help you with exploiting extensions. And that's it. Do you have any questions? Yes.
Does the extension have access to get user media without nagging the user or asking for permission?
There's probably API for it. I haven't really paid attention to the latest API additions, but the thing is that every 2 months or something, there's some new API in Chrome extensions that allows you for, there was, for example, a year ago, extension already could use the text-to-speech engine, so there was even a payload which simply said, oh, you're doomed. Yes.
If that were the case, you could actually hijack the user's webcam, and you can even go further with future Chrome versions. You can get content on the entire screen, not just the browser, the entire screen.
Mm-hmm.
It's a bit scary.
We could look it up in just Google the documentation for the next version of extensions. But the thing is, you're usually limited to what permissions does the extension have. So either you package your own malicious extensions, which is a vector of attack, but it's not that common lately. But when you have the extension v2, you would need 2 vulnerabilities actually. One in insecurely accepting something from the content script and launching the user media API from that, and the XSS in content script. Yes?
Is there actually a way for the developer of version 2 extension to make the content security policy less strict?
Not so much. I mean, you cannot enable inline scripting, but you can get the eval back. You can say unsafe eval, use the unsafe eval construct, but you have to do it manually. And in fact, a lot of extensions do, because they use the templating libraries. And that's, I even saw the discussion when they were discussing whether it's a good thing to allow unsafe eval or it's a bad thing. They needed to do this because a lot of extensions used eval for templating. Also, you can relax relax the CSP in the way of specifying the sources of images, and other types of content, but you cannot load stuff from HTTP, especially the scripts cannot be loaded from HTTP protocol, only HTTPS. Other than that, you have a sandbox. There's a way to actually execute unsafe code, untrusted code in a sandbox. So with the sandbox, you also have the post message mechanism to query it. Yeah.
We have a second question. Do you know if there's a special reason why they allow the cross-domain I mean, they could hide it behind the permission and just allow it in the.
I would imagine because a lot of extensions are actually, let's say, just a part of an ecosystem of a certain companies. Like you have a third-party bookmarking service, whatever. You have Digo. You have a lot of Evernote. You have a lot of those kind of applications which have their own mobile clients, whatever. And extension is just a part of this ecosystem, and they directly usually query the API from cross-domain, from the content script, not from a view page. And I would say that's the reason.
So they just allow it because it's the most common thing.
Yeah, it's rather people use it. Yeah, let people have their thing. Okay, thanks very much. Enjoy the evening.